Hi, today we're going to be learning about drawing and interpreting global graphs. First, I just want to go through a few things you need to know when you're going to be working with global graphs. The first thing is the different types of variables that we get. A graph is a graphical representation of the relationship between two variables. The first is the independent variable. It is plotted on the horizontal axis and it is not affected by changes in the other variable. Then we get the dependent variable. It is plotted on the vertical axis and it changes based on the independent variable. Okay, then we get two different types of graphs. We have linear graphs and non-linear graphs. If we look at a linear graph, here's an example over here. If I join up the points in a linear graph, you'll find that they form a straight line. So a linear graph is a straight line. Here's an example of a non-linear graph. If I join up the points over here, you'll find that it doesn't form a straight line. So a non-linear graph is not a straight line. Okay, then we have constant, increasing, and decreasing graphs. A constant graph doesn't go up or down. As you move from left to right along the graph, it stays horizontal. It does not go up or down. An increasing graph goes up as you move from left to right, and a decreasing graph goes down as you move from left to right. Next, we have the maximum and minimum points. The maximum point on a graph is the highest point of the graph. It is the point where you have the highest value of the dependent variable, and the minimum point is the point where you have the lowest value of the dependent variable. The maximum point looks the highest on the graph, and the minimum point looks the lowest down on the graph. Then we have discrete and continuous graphs. Discrete graphs are used for data that is counted, and continuous graphs are used for data that is measured. In discrete graphs, the points are not joined, but in continuous graphs, the points are joined by a line or a curve. With discrete graphs, readings can only be taken at distinct points. So like over here, I can't take a reading in between the 1 and the 0 and the 1. I have to take a reading at 0 or at 1 or at 2 or at 3 and so on. But with continuous graphs, readings can be taken at any point along the graph. So here I could take a reading at 1 or 2 or 3 and so on, but I can also take a reading at 1.5 or at 2.25. I can take readings anywhere along the horizontal axis. I can find out what the reading is. Okay. Right, let's go on to an example where we're going to be working with a global graph. In this example, Sarah is conducting a science experiment where she is measuring the growth of a bean plant she planted in a pot. She recorded its height from the moment it began to sprout, which was week 0, and continued to measure it carefully each week from the soil to the tip of the tallest leaf. The following data shows the plant's height over a period of 6 weeks. So you can see in the table over here, they tell us these are the weeks. So we've got week 0, week 1, week 2, and so on up to week 6. And then we've got the height of the plant that she measured at each of those points in time. I'm going to give you 1 minute to answer these questions where you have to determine if the data is continuous or discrete, and which variable is independent and which variable is dependent in this example. So you have 1 minute to answer those 3 questions. Okay, so you should have found that the data over here is continuous. It's continuous because we measure the height of the plant, and we also are able to measure the time. And you could take a reading in between 0 and 1. You could find out how tall the plant was at half a week and so on. Okay, so this is continuous data. Then the independent variable in this example is the week. Okay, time passing is not dependent on the height of the plant. It's going to pass, the time is going to pass regardless of what happens with the plant growing. Then the dependent variable is the height of the plant. The height of the plant is dependent on how much time has passed. Okay, now you need to go and represent this information from the table over here on a graph. I'm going to give you 2 minutes to do that. Okay, so let's have a look at what your graph should look like. So over here, you should have a heading for your graph. It could be something like plant growth over weeks. Then on your vertical axis, you've got the height of the plant in millimeters. That is your dependent variable, and your independent variable is on your horizontal axis. That's the number of weeks. Then your graph should look something like this. Okay, you should have at 1 week, it was 20. At 2 weeks, it was 35. At 3 weeks, it was 60. At 4 weeks, it was 80. At 5 weeks, it was 100. And at 6 weeks, it was 115. So that's what your graph should look like. Okay, now you're going to be using the graph to answer the next few questions. I'm just going to give you a few seconds for each question, and then I'll go through each of the answers with you. Okay, so here's the first question. Would you describe the graph of the plant as linear or nonlinear? Okay, you should find that this graph is nonlinear because it is not a straight line. Right, the next question. Describe how the height of the plant changes over the weeks. Is it increasing, decreasing, or constant? Okay, so this graph, if you go from left to right, it is going up, which means that it is increasing. Right, then the next question. What is the maximum height the plant reached by week 6? Okay, you should have found that that is 115 millimeters. If you look over here at week 6, that was 115 millimeters. Right, then question H. Estimate the height of the plant at 2.5 weeks or 2.5 weeks. Okay, so for this question, you need to go and look over here. 2.5 or 2.5 is exactly halfway between the 2 and the 3. So it's this point over here. So if we go up here, then it's about over there. So that is going to be about 47.5 or 47 or 48 millimeters. So you could have had 47 to 48 millimeters for your answer over there. Okay, so this is an example of where we're able to take a reading at any point along the graph. It doesn't have to be at the exact, like the 1 week and 2 weeks and 3 weeks. You can take a reading at any point. Okay, then we have question I. Do you think the plant's growth will continue at this rate forever? Why or why not? Okay, so you should have said that no, it's not going to continue forever, because if you think about a plant, it doesn't just carry on growing forever and ever and ever. The plant's growth will likely slow down or stop eventually. And that is how we draw and interpret global graphs. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.